Good evening, everyone, and welcome to Straight Science. Straight Science is an evening seminar series put on by University of Alaska Fairbanks Northwest Campus in Nome, and also University of Alaska Fairbanks, UAF, Alaska Sea Grant. And tonight you're in the home office because our speaker is in Seattle, and he and two of his biologists we thank them right off the bat. It's an hour later for them, so they're doing extra duty just by showing up. So our speaker tonight is Michael Cameron. He is with NOAA's Alaska Fisheries Science Center in Seattle, and he is the leader of the Polar Ecosystem Program, which is in charge of all the NOAA research on seals, sea lions, on seals, and then NOAA, NOAA, is in charge of management and research of all the seals, all the sea lions, and all the whales when it comes to marine mammals. So tonight we're hearing from the Polar Ecosystem Program from the ice seal and harbor seal biologists. So Michael Cameron is no stranger to Straight Science and no stranger to the region. He's got Erin Moreland and Heather Ziel are also online, and they'll be standing by ready to answer and help him at any time if he so needs it when he's talking about the ice seal research. They are senior biologists with the Polar Ecosystem Program. We'll have questions at the end unless they're super burning. And we're going to hear tonight recent research results on bearded, ringed, spotted, and ribbon seals. And we're going to hear also, and we should be kind of excited to hear what the plans are for the research for 2024 spring, some of which, spoiler alert, will be based out of Nome. So buckle in. We'll hand it over to Michael Cameron. Take it away, Michael. We're really glad you're here.
Great. Well, thanks so much, Gay. I really appreciate it. I love talking to this group. The science series has been really informative and really a benefit to all folks who want to learn more about research and ongoings in the Bering Sea. So I'd like to thank everyone, you in particular, for the opportunity to talk to you today about our program of research. For efficiency, this is sort of a long presentation. I'm going to be going over some of it very quickly, and some of the slides I'm actually not going to be going over at all much, just kind of quickly flipping through them. But there is a lot of information in here that I want to make available. So I've made a PDF of this presentation available to anyone who would like it. Just feel free to email me at my email here at the bottom. It says michael.cameron@noaa.gov. Or you can email Gay, and I'll be happy to send you a copy of this presentation. As Gay mentioned, I have two colleagues with me today, Heather Ziel, who leads all of our vessel-based or our ship-based tagging and sampling efforts for ice-associated seals, and also Erin Moreland, who's the leader of our ice seal aerial survey program. They're on the call, and they're going to be available to give a lot more detailed answers to your questions than I can give. But just for efficiency, I'm going to be giving pretty much the entire presentation, and then, of course, they can help answer questions at the end. So the Polar Ecosystems Program, or PEP, as we're sometimes known, as Gay mentioned, we're part of NOAA Fisheries, Alaska Fisheries Science Center. We're based out of the Marine Mammal Laboratory in Seattle. And I wanted to take some time right now first to introduce myself and to introduce our program of research before continuing on to future work. So a little bit about myself. My name is Michael Cameron. I'm the leader of the Polar Ecosystems Program. I have a lot of experience studying seals in polar regions, both Antarctica and the Arctic, and a lot of years also working with co-management. I was born in Portland, Oregon, and this is my family, Colleen. She was born in Texas and moved to Seattle when we got married in 2002. I have two children, Colin, who's 13 years old. He was given the Inupiaq name Anaway by John Goodman of Kotzebue, Alaska. And my daughter, Kate, she just turned 10, and she was given the Inupiaq name Selekkutok by Billy Adams of Uktiapik. And I wanted to bring that up because I believe that my relationships that I've developed with members of the subsistence coastal communities that subsistence hunt over the last decades have really informed the way that I conduct research and understand the world around me. My understanding wouldn't be nearly as complete without all of the discussions that I've had over the kitchen table and eating sandwiches on a boat waiting to capture seals. So I was honored that these gentlemen were willing to bestow Inupiaq names on my children. As Gay mentioned, I work for the Polar Ecosystems Program, and we monitor and study 4 species of ice-associated seals: the ringed seal, bearded, ribbon, and spotted seal. And our work also includes harbor seals in Alaska waters. Although this presentation, I really won't be talking about harbor seals. A little bit of context for why we conduct work. The AFSC stands for the Alaska Fisheries Science Center. There are indications that seals are responding to changes in the Bering Sea. We have some evidence of a decline in the body condition or how fat animals have been. And so it's more important than ever to be monitoring these animals. We know that there are changes in sea ice lately that we need to understand the impacts of. In order to collect information on these seals, a lot of the monitoring we need to do can really best or only be measured in the spring. We recognize that this is the time when a lot of local residents need to hunt marine mammals and other animals for subsistence purposes. We believe, and we've shown, that we can conduct this work as long as we communicate a lot and often and early with different communities. We believe we can conduct this work without impacting the success of subsistence hunters. NOAA has a mandate under the Marine Mammal Protection Act and the Endangered Species Act. These are 2 laws in order to manage and conserve marine mammals as part of their ecosystems. The Marine Mammal Protection Act is very useful because it allows NOAA to co-manage these species directly with indigenous peoples and tribal nations along Alaska. For ice-associated seals, the primary organization that we work with is the Alaska Native Ice Seal Committee. The Ice Seal Committee has representatives from 5 of the different regions or boroughs. Each of those representatives come together a couple times, once or twice a year, in order to have meetings about ice-associated seal research. There's also an Alaska Ice Seal Working Group that includes the Alaska Native Ice Seal Committee, as well as representatives from the Alaska Department of Fish and Game, other educational and institutions. Together, we develop what's called an Alaska Ice Seal Research Plan. So once a year, we all get together and decide research that we think is most important. All the projects that I'm going to be describing here were included in that plan, and as such, they were discussed at length at the Alaska Native Ice Seal Committee meetings. For those of you in the Bering Strait region, your representative is Chuck Manidaluk, and Ben Payana is the hunter representative. So as I mentioned, we monitor and study bearded, ringed, spotted, and ribbon seals, as well as harbor seals. Most of the way that we do that is to conduct aerial surveys and also conduct vessel-based projects or projects out of villages that allow us to capture animals, to sample, tag, and measure them. I'm going to be talking about our current projects that we have in those 2 areas. Starting first with our project of vessel-based sampling. So ultimately, we want to understand how many seals that there are in the population, what is their abundance, and where are they, what is their distribution. We want to understand their seasonal movements, where they go and why, and we want to understand how healthy they are, and most importantly, given changes in the Arctic, how they're responding to changes in their habitat, specifically, or perhaps most importantly, changes in their sea ice habitat. To do that, we need to access the animals. And in order to access the animals, we use research vessels like this one here called the Oscar Dyson. The Oscar Dyson is a NOAA vessel that we are often able to use. We've been able to use the Oscar Dyson many times over the last, and other NOAA ships, many times over the last couple decades in order to get access to the sea ice edge. Usually, more and more lately in April, we're able to use these ships to go to the southern edge of the Bering Sea pack ice in order to launch small boats to capture seals. Once we see a seal on the sea ice, we'll launch 2 to 4 small boats, quietly move through the pack ice, communicate over radios with one another until we're able to surround a seal on an ice floe and jump out and capture it in what is essentially salmon landing nets, as in the bottom photo there. For the last decade or so, we've been able to conduct this work every other year in even years in April. 2020, of course, was an anomaly. We had to cancel our work due to COVID restrictions. But as Gay mentioned, we are planning to come back to the Bering Sea next year in 2024. We hope to have an extended cruise in April and May of the Bering Sea. So longer than our normal cruises of 3 to 4 weeks. This one we're hoping can be up to 6 weeks. So we're very excited. And there's a possibility that we may be able to repeat the work again in 2025. Because of where we're operating, most of the animals that we're capturing during these cruises are ribbon seals and spotted seals. Once we capture an animal, we have a complete workup that we follow in order to make sure that capturing the animal can benefit, be able to collect the most amount of data. First and foremost, we put satellite link tracking tags on them. These are tags that communicate with an overhead satellite and are able to tell us information about their seasonal movements. These tags can remain on anywhere from 1 month to 3 years, giving us information on where they move at different times of year and how their movement might be related to environmental conditions like sea ice or water depth. So those tags provide information on movements and the foraging behavior. Another really interesting part about those tags is that they give us information on the timing of when a seal hauls out onto the sea ice. When we conduct aerial surveys, which I'll talk about in a minute, we can only count the seals that are hauled out on top of the ice. We know that whenever we fly and we see seals, there's lots of seals underneath the water that we can't see. So we need to be able to correct for that proportion of the population that's under the water during the time we conduct the surveys. To do that, we have to get a record of the timing of when different tagged animals haul out of the water onto the sea ice and when they go back into the water. By collecting that information from hundreds of different animals, we're able to develop a good estimate of the proportion of the population that might be underwater whenever we conduct an aerial survey. In addition to tagging, we also have a very robust program collecting measurements and tissue samples, measurements like length and girth and mass, how heavy the animal is. We always try to have a veterinarian on board, so this cruise to work with us. So essentially, we're giving these seals a full physical, the same way you would when you go to see your doctor. At this time, then, we're able to use these blood and tissue samples we collect to be able to collect information on the seal's health and condition, and also understand a little bit more about how genetically different they might be from seals in other areas. More recently, we've also been conducting uncrewed aerial system flights, essentially conducting flights off of the ship in order to take images of seals. This is important because we're now able to estimate the body condition, how fat an animal is, just by taking photos of it. This is important because, as I mentioned in the past, we've had some evidence that there's been a decline in the body condition, how fat animals have been over the last decade. And so by collecting more and more data, we're able to get a better idea of what that means. This is just a short example of the sorts of information that we can get from seal movements. These are tracks of some of the different species, bearded, ribbon, and spotted seals. This is sort of a combination of all the different tracks of all the seals we've tagged, so not just one seal per slide. As I mentioned, we believe that we can conduct this work, and we've shown that we can conduct this work without impacting subsistence harvest activities. To do that, through working with the ICEAL committee and talking with representatives from lots of different communities, we've developed a number of different regulations or rules that we have for ourselves in order to minimize any impact we might have. At the most basic, it's where we operate. The ship will never be operating within 12 nautical miles of the coast anywhere. And we also won't be operating within 30 nautical miles of any whaling, sealing communities, or known whaling or sealing camps in the area. And this hashed sort of gray outline that you can see around the coastline shows the area where the ship or our research for this work will never be conducted. In addition, if we ever see larger groups of walrus or large groups of whales or any hunter at all, we'll stop our work and move to a different location. Most importantly, of course, is the fact that we maintain constant communication. We have a listserv, basically a long list of emails that we will email every single day to let folks know where we are, exactly where we are, what our plan of the day is for that day, and what we plan to do the following day, along with a map showing exactly where we are relative to the coast. And where it's possible, we also include information on the most recent sea ice imagery. By having this daily communication with hundreds of people, we're able to make sure that we can mitigate any potential conflicts before that they happen. Of course, there's always the possibility of people that don't get the opportunity to see these emails. And so at the bottom of that list, we also provide multiple ways to contact us: emails, fax numbers, cell phone numbers, satellite phone numbers, as well as the radio frequencies that we follow. So again, like hunters, we don't want to disturb seals. Disturbing seals impacts our research in the same way that disturbing seals might be impacting hunter success. We have the same goals in that way. Capturing an animal requires quiet and stealth, so any disturbance would be impacting our monitoring. Over years, of course, we've been developing these rules, but there's always room for improvement. So if folks on this call or anyone else can think of other ways that we might be able to continue to mitigate our potential impact, as small as it is, on the subsistence hunt, I ask you to reach out to me and let's have a conversation. Most of the time, our operations are well away from all of the buffers that I'm showing you here. Nearly all of our surveys, except for 2018, were conducted in the area sort of to the west of St. Matthew Island. I think maybe you can't see my cursor, but I'm circling it around St. Matthew. It's the lower left-hand part of the screen where it says operating area 2007.
We can see your, this is Gabe. We can see your cursor. Yep.
Great. So nearly all of our expeditions have been to that area, far away from subsistence hunting communities. We also have a longer history of being able to partner with the ICEAL committee and with various communities within the Bering Sea. I'm just going to show a couple of the different projects where we have been able to work with various folks and various communities that were recommended to us through the ICEAL committee. For example, in these photos I'm showing you now, you may recognize Micah Padiki or Peri Pungawi or others who were able to participate with us during some seal captures we conducted aboard the Coast Guard cutter Healy or the Polar Star. We conducted aerial surveys. And as I mentioned, in 2002, we worked with the ICEAL committee again to recommend a representative from a coastal community to participate aboard our cruise aboard the Oscar Dyson. The ICEAL committee recommended that COERIC should recommend the first of these representatives, and they identified Austin Amosic. We hope, we plan, we expect to be able to repeat this same offer continuing in 2024, where we're hoping to be able to pay for representatives from Alaska Native subsistence hunting communities to work with us together on these research cruises. I think as I mentioned, some of the best times or best ways we have to be able to learn from each other is actually doing the work together and then sitting around the dinner table afterwards and talking about what we saw. We learned a lot, I think, and I think that it's been a mutually beneficial thing that we want to continue. So I mentioned this is a paid position, and we'll be working again with the ICEAL committee in order to help identify folks. It's possible we may have the opportunity for 2 different representatives from this trip. We're hoping to have 2 3-week cruises, so 1 representative per each of those 2 periods. If you're interested and would like to be considered as one of the participants aboard these cruises, I urge you to reach out to your representative from the ICEAL committee to tell them that you're interested, and they can make sure to make a plea for you during those discussions. So as I mentioned, we know that there's been changes in the sea ice of the Bering Sea. We know that the extent, how far south the sea ice gets throughout the year has been trending downward, meaning there's been less and less ice year after year on average. Sea ice is, of course, very important habitat for ice seals, especially in spring and summer. They're called ice seals after all. They use sea ice as a platform for giving birth, for nursing their young, for molting, and for resting. But if we expect that there's a change in the amount of sea ice, which is what's predicted from models of sea ice extent going out to the end of the century, likely we can expect some negative implications for all of the populations of ice seals. Potential for increased predation, reduced survival or production, potential for increased parasites, and overall poor nutrition and body condition. This chart at the top shows model runs, basically of the total amount of sea ice that computers have estimated that might be existing in the Bering Sea going out to the end of the century, 2021. The red line is actual estimates. The gray spaghetti in the back is sort of like hundreds of different model runs. And then the blue and pink lines on the front are averages from different models. In all of them, we're showing a decline in the amount of sea ice. And the estimate is the decline in that, how quickly that decline occurs is expected to speed up around mid-century, 2050. As I mentioned, we have evidence that there's been a change in the body condition. Body condition is basically just an idea of how heavy an animal is for how long it is. We're finding that there's been a reduction in body condition of pups for all of the species that I mentioned, except for ring seals, which we didn't have a large enough sample size to conduct work on. And we're also finding a significant change in body condition for ribbon seals of all age classes. Obviously, there's also been changes in the ecosystem that we've been seeing, even if we didn't notice anything about sea ice. Under the Marine Mammal Protection Act, there's the possibility of the federal government declaring something called a unusual mortality event, or UME. A UME is defined as sort of a stranding event that's unexpected, and it has a significant number of animals dying off, marine mammal populations, and demands immediate response. In just an 8-year period, the federal government has declared 2 different UMEs for different reasons. The one from 2011 to 2016 was characterized by animals with hair loss that were lethargic. They had lesions over their body and were of poor body condition. Ultimately, the program couldn't determine the cause of that. After an extensive research, they were not able to directly identify what the cause of that UME was. But shortly after that, again, there was another UME that was declared from 2018 to 2022. This one was slightly different. It involved mostly young animals that were emaciated or starving, very poor nutrition, suggesting that there was a bottom up, or this was the result of animals being unable to find enough prey and were hungry. There's evidence that this was likely related to the marine heat wave event that you probably remember from 2018, a record low sea ice extent. So, and similar conditions in terms of emaciated animals were found in other species at the same time, for example, piscivorous or fish-eating birds. So the work that we conduct was used directly in these research efforts to understand the cause of these UMEs. But it's important to conduct this work even when there's not a UME, because it helps to develop a baseline against which we can characterize the severity of a UME. Most of these animals are top-level predators, and they're foraging generalists, meaning that they're going to be feeding on lots of different food items. They're not specifically only eating one type of food. What that means is a starving seal suggests that there's a deeper ecosystem-wide cause that we need to understand. They're sort of best understood as the canary in the coal mine. I wanted to mention a little bit about this. Some of you may know that two of the species that we study, the bearded seal and the ring seal in US waters, were declared as threatened under the Endangered Species Act. The listing of threatened is different than the listing of endangered. Endangered means in danger of becoming extinct in the foreseeable future, and threatened means in danger of becoming endangered. So it's sort of a way to raise the alarm to say, hey, we need to start paying attention to this. The bearded and the ring seals in the US waters were unique in many ways in how they were listed as threatened under the Endangered Species Act. And that's because these populations currently for bearded and ring seals are actually high. There's high numbers of animals, which is perhaps counterintuitive as to why they might be listed under the Endangered Species Act. But it's because of that earlier slide that I mentioned, showing that the computer models are predicting a reduction in the amount of sea ice over the Bering Sea and throughout the Arctic in the rest of the century. Understanding how important sea ice is to ice-associated seals, it raises the interest of folks as to what will happen to these two species as the predicted amount of sea ice declines. So by listing them as threatened, it forces us to take a closer and more intense look at them before reductions in sea ice start directly impacting them significantly. So a lot of work that we do, other than the vessel-based work that I've been going over, a lot of work we do is conducting aerial surveys for ice-associated seals. These are essentially flying over large areas of sea ice and being able to, quote, count the seals that are underneath the aircraft that we can see. The goal of these surveys are to estimate the abundance, how many there are, and the distribution, where they are, of seals and also of polar bears. We first started this work in 2012 and 2013 in the Bering Sea. It was an international effort at that point. We were able to work with the Russians, who were conducting near identical types of surveys on their side of the international date line. And then we were able to come together and combine those two surveys together into overall estimates of abundance and distribution for the Bering Sea, and again for the Chukchi Sea in 2016. This work is conducted in the spring when seals are using the ice to give birth to their pups and to molt. This is the time of year when the most numbers of seals are hauled out onto the sea ice. And it's also a time when we have a lot of good data from the satellite tags that I mentioned a little earlier on. So by combining all these different data sources, we're able to get good estimates of the abundance and distribution of seals in these regions. In the past, early on, prior to 2012, these types of surveys were conducted essentially by low-flying aircraft, either fixed-wing or helicopters. And basically, either with someone looking out the window and counting what they see as the sea ice goes by underneath, or taking photos of any seals they see and then going back and counting the photos. Those were good, but eventually we recognized, as I mentioned, disturbance is something that we want to avoid. The lower flying loud aircraft had the potential to disturb animals. We don't want disturbance, and so we want to fly higher. If we're going to fly higher, at some point the seals will be too small for a person to be able to see. And so we started using instruments, basically a swath of cameras mounted on the underside of the aircraft that are taking pictures of everything underneath the aircraft. I'll show you a little bit more about that in a minute. We finished our first suite of surveys of the Alaska waters by conducting surveys in the southern Beaufort Sea in 2021. All of this work again was discussed with multiple conversations with the Ice Seal Committee, coastal communities, and lots of different co-management organizations and other groups. We are hoping that we are expecting that we will be able to repeat these sorts of surveys again in the Bering Sea next year in 24. And again, we'll be conducting that work in April. And again, NOAA will become one of our primary hubs for the aircraft flying in and out. And I'll show you one of those maps in a minute. We're also optimistic that in 2025, the year afterwards, we're going to be able to conduct a much larger survey. We're hoping to be able to survey the Bering, the Chukchi, and the Southern Beaufort all together in 1 year, all in 2025. Plans for both of these surveys are still being made. Obviously, plans for 25 are farther out. But as we get closer to that, I'll be sure to come back to Straight Science to give you results of previous surveys and let you know what we're going to be doing in the future. So as I mentioned, we have a camera suite that's mounted in the belly of the aircraft that's now basically we're basically mowing the lawn, as we call it, surveying the area underneath the aircraft in these long flights. We're benefited now, in addition to the color cameras, which is essentially just any camera that you're thinking of just takes color pictures. We also have other sensors that help us to better detect seals on the ice. The most important of that is a thermal camera or an IR camera. On the left-hand side is an example of a thermal or an infrared image. And on the right-hand side is the exact matching image with a color camera. If you look at these two dots here in the thermal camera, you can see them in the corresponding color camera and identify them as bearded seals. What this allows us to do is we're able to use the thermal signature of a hot seal against the cold background of the sea ice to easily be able to see a seal while we're flying over it, be able to look at the corresponding image quickly and ignore most of the images that have no seals in them at all, and then be able to identify these seals to species. We're constantly improving upon this method. We're now getting better and better at using artificial intelligence and other image recognition processes to better identify these hot spots on the ground and to better identify the corresponding image as a seal, even to species, sometimes in the corresponding color image. I'm going to go back to that other picture for a minute. Those manned surveys that I mentioned, where we had people looking out the window and either taking photos or just counting the seals that went by, those were normally happening at about 300 to 4 or maybe 500 feet. With the aircraft we're using now, we're able to fly between 1,000 and 1,200 feet, much higher. We're also able to fly faster. In 2021, we were able to fly in an airplane called a Twin Otter, which can fly at about 120 knots. When we're on manned aircraft, we can only fly at about 90 knots, or else the animals are moving by too quick for observers to count. We're constantly trying to improve these methods, not just to increase the amount of data we can collect, but also to minimize disturbance, because again, disturbance is not useful for our research. So from 2012 through 2021, this is the full area that we were able to survey in conjunction with our Russian partners on the other side of the international dateline. Significant coverage of the whole area, the entire range of the spotted and ribbon seals are covered in here, as well as a significant portion of the Pacific subspecies of bearded seal in these areas. This was a monumental effort over a decade with multiple countries working together. As I mentioned, the other set of sensors that we had were ultraviolet sensors, in addition to the thermal and color cameras. Those are used to help identify polar bears from these surveys. And we worked on that project with our Canadian colleagues. So for the next couple slides, these are some of the slides that I'm going to be going through quick, but that if you're interested in the data, feel free to call me or contact me for the PDF so that you can look at it a little more closely. What I'm going to do here is just show you how to read these slides for when you want to take a look at it a little bit later. Right now, I'm showing you an image of how our model estimates abundance for the Chukchi Sea using the data from 2016. The region up here is identified in the upper left-hand corner by the circle. This is the area that we're surveying. Bearded seal and ring seal here. The number in bold on top is our best guess at the abundance estimate of those species within that area, within that circle. So 147,000 plus bearded seals, 592,000 plus ring seals. Underneath that, however, there's a gray range of numbers. For bearded seals, 144,000 to 190,000. What that means is that we have a 95% confidence that somewhere in between these two numbers, 144 and 190, that's where our estimate is. But our best estimate is that it's 147. That's how to read that. Conducting these surveys is complicated, and it's complicated even more by the fact that we can't conduct this survey all in one day. And so because we're going to be conducting these surveys over weeks or even over the courses of months, we know during that time, especially in April and May, the sea ice is changing a lot. That is, it's reducing. And that's changing the area we can survey, but it's also changing where the seals choose to haul out. So we have to use sea ice as part of our model. The way to look at this then is every column shows a different day. For example, April 7, May 3rd, or May 31st. The first row gives you an idea of the sea ice concentration. And then the next two rows show you the distribution and abundance of seals in the area. This is the same sort of slide just for the Bering Sea and just for the US side of the Bering Sea. So I won't be going through this quite as clearly, but the interesting thing from this is, especially in the April time period for different species, you can clearly see how they change their distribution, both species to species and throughout the year. So for example, for ribbon seals, we see that they are nearly all identified right or located right at the sea ice edge, and that they're higher concentrations the further west you go. For spotted seals, we see that they're also mostly highestly concentrated around the southern edge of the sea ice, and they're more or less evenly distributed about that part. If you think about why we tend to conduct our work just west of St. Matthew, this is it. You get the highest number of ribbon seals and a high number of spotted seals, all in that location, with the potential for being able to see ringed and bearded as well in those areas. So that's one of the main reasons that we conduct our work in April over there. As the seasons progress, as the time progresses through April and May, the sea ice is changing, and these maps can show you how the distributions of these different seals change. And this is just I'll back up. As I mentioned, this is just the US side of the Bering Sea. This table combines estimates from the US and the Russian surveys on the Western Bering. So we're planning to conduct surveys in the Bering Sea in 2024, and this is our current best case scenario of where we're planning to fly. My father was in the military, and he would tell me that the best laid plans all fall apart at first contact with the enemy, and field plans are the same way. The second we get out into the field, weather and sea ice conditions tell us where we're actually going to fly. So these are not the exact flight routes. These are just the ones that we're using to plan. The actual flight routes we take every single day will be deciding based on what we saw in previous surveys or the days previous, where the sea ice is, where we expect to see fog, and if we know that hunters are operating in one area, we'll also try to take that into account. As you can see, Nome is going to be a primary hub for a lot of the work that we plan to be doing, as well as St. Paul Island being able to cover a lot of the area to the south along the southern edge of the sea ice in these areas. This time in 2024, luckily, we're going to have access to a different aircraft called a King Air. This is the Twin Otter that we were able to use for previous surveys. And the King Air is the survey that we're going to be using in the Bering Sea in 2024. It's much faster, and it has a longer range. What those together allow us to do is they allow us to conduct the work in much less time. Previous surveys of the Bering Sea required us to have 2 different aircraft flying for between 5 and 7 weeks, depending on the years, with over 200 flight hours. Now we believe we can cover the area with good weather, needing only 1 aircraft, and can be able to conduct the work with just about 75 to 100 hours of flights. What this means is 2 good things. 1, we're able to compress the amount of time that we're able to conduct the work. This is good because the smaller the window we conduct our flights, that means the less we have to care about the impact of a changing sea ice. So that helps our statistics, which should be able to improve our estimates. The other thing is it's safer for us because we're not flying around as much, but it also means that the less time we're in the air, there's less potential overall for any disturbance. So half as much time in the air is a significant improvement this year with these aircraft. I wanted to bring folks to their attention to this flyer. Looking at it, it's mostly obsolete or mostly over, but this is a flyer that the Marine Mammal Laboratory in Seattle puts out every single year in about January. It identifies all of the different fieldwork projects that are happening on marine mammals in Alaska in a year. Each one of these icons corresponds to a specific project. The month that these projects are occurring is identified with a checkbox in this grid to the left. And on the back of this flyer, each one of these projects has a small abstract about what the project is, why they're doing it, and what data they plan to collect, as well as a point of contact, usually an email for the lead on that project. Every year, we produce this, and I provided the link for this year's Marine Mammal Fieldwork Flyer. In January, we'll be producing another one, so this link will just change to 2004. So I recommend that in 2004, in January, you go to that website and you can see all the work, where, when, why, and how on marine mammals is going to be happening in Alaska. It's all part of our goal to increase awareness, increase communication. The more we communicate and work with one another, the more it's best for everyone. With that in mind, we had a specific workshop this year in March, coincident with the ICEO Co-Management Committee. We spent essentially a day working with the ICEO committee and representatives from the ADF&G and from lots of educational institutions coming together to find ways that we can best conduct our work without impacting the hunt, that is, by being able to protect food security. Our case study for this was actually our aerial survey project. There's a lot of slides here that I'm not going to go through. This is another section that I wanted to make sure folks had, though. So if you are more interested in this, please ask for the PDF and I'll send it to you. The focus that I want you to get that I would like for you to take away from this, though, is that we are motivated to make sure that our work does not impact subsistence hunters, but also that we're working directly with communities to collect the types of data that they want. By being able to continuously improve our methods to reduce disturbance, we've been able to show that we have similar needs, and by increasing those conversations, we're able to learn more about ways that our research can help other communities. So similar to the work that we had involving Alaska Native participants, subsistence hunters on the vessel-based projects, we're also planning to work with the ICEO committee to help identify representatives from communities to participate in the aerial survey work. Again, this will be paid positions. These will be shorter duration, probably on the order of a week versus 3 weeks or 6 weeks for the vessel project. Again, we'll be asking the ICEO committee for names of folks that we should be working with. So if you're interested, I recommend that you reach out to those representatives. Through these discussions, we learned that folks were, by and large, happy with the work we were doing, happy with the communications we've been having, and felt good enough that in most cases, there's very little risk, if any, of disturbance for the hunt. So the conversations then turned to other ways that the work can help. So by being able to have representatives from different communities aboard these aircraft, they might be able to see things that are interesting, recognize them as being interesting or important to a community that we might not. We could break off effort and go over and fly around something. Examples were being able to fly over river mouths to understand when they're first breaking out, when the ice dam breaks, or being able to fly out different communities to understand layouts. With our high resolution cameras, this is something that we can provide very easily to various communities. Overall, the number one thing, of course, was communication. Those emails that I mentioned that we sent out for the vessel-based work are the same sorts of emails we send out every single day for the aerial survey work. We're constantly collecting names. I think my slide I saw said 200. I think now we're actually well over 400 names, and at least 100 of those are actually heads of community organizations. But we always want to continue working to talk to folks directly. And so this year in particular, I've gone to a number of different communities, giving essentially the same presentation that you've heard today, talking a lot about our work and soliciting information about ways that we can work together. And those have been very helpful, I think. And so we're very excited about being able to have a successful project of vessel-based research and aerial surveys in next year. And that's it. And I'm screen sharing.
All right. Well, thank you very much, Michael. And while people are thinking of their questions, this is a good time to give Michael Cameron some love in the chat box. It is never easy to be a straight science, any kind of public speaker, much less a straight science speaker. And we very much appreciate, look how dark it is for him, behind him. Look at those windows. So thank you very much for taking the time to talk to us tonight. I think that it's pretty exciting. I know I've got questions, Erin, and there's Dean Stockwell. Hi, Dean. Good evening. Go ahead.
Yeah, hi, Michael. Nice
Hi,
talk.
Dean.
Really enjoyed it. I'm a phytoplankton person, so
Mhm.
give me some give me some well, anyways, population assessments, whether they're terrestrial or marine, is always difficult, and it's fraught with many varying parameters. I know from my work with NSF that the military images of penguins in the Antarctic had been used to kind of assess their population distributions. And I was wondering if you could perhaps make contact with somebody at NSF and make a contact with them to see if they could help you with seal identification in the Arctic. All of this is very important, and I know you're just dealing with all of this, and so if I go back to your slide 16, is what percentage decline of the population did your graph really show over the course of those years? It's important to see the decline. And, and while you're looking at that, have you noticed a change in the stomach contents in the diets of or the prey of those organisms you're looking at? And I'll leave that to you. Sorry.
So I'll put that slide up here for a second. So I think I'm sharing this now. Let me know if that's
there you
not
are.
the right.
Yep, you're up.
Hold on. So you brought up 3 points, and I'll try to. This slide is the one I think you're interested in. So your first point was about being able to use satellites to count the animals. So I'll say that our program is called the Polar Ecosystems plural program, in part because we used to conduct nearly all of our work in the Antarctic, and then a couple decades ago we switched to mostly Arctic. I am familiar with the work that the folks have been using to estimate penguin colonies from satellites. They're not counting individual penguins. Penguins are a lot more colonial. They clump together. They're patchy, and so what they're doing is they look at an area of penguins, and are from that area of penguins, knowing from ground counts, they're able to get good estimates of the number of penguins per square whatever. And then if they know the area from the satellites, they can make estimates of abundance. That doesn't work as well with animals that are more solitary and don't clump, like ice-associated seals. We have actually looked at the potential for satellite imagery, and ultimately we determined that it's not good enough to be able to identify a seal from a melt pool. And even if that reliably, and even if it were, that is an area that we wouldn't be able to determine the species of the seal. So the resolution of those satellite products aren't quite up to what we need. It would probably be useful to other marine mammals that clump a little more, like walrus, for example. But unfortunately, it won't work for the types of seals that we study. I think your next question was about this slide here. You're asking about the percent change. Just by looking at this, I don't know the exact percent change, and I hesitate to give a number. It's roughly half of the amount of ice. I do have graphical maps. I do have maps representing sort of what the sea ice extent is supposed to look like in different decades. Maybe I should include one of those 2 slides, sort of current and at the end of the century, to give folks a better idea of what low ice means. I can
So-
say that if you remember what the sea ice looked like in 2018, where the ice edge in April was, was north of St. Lawrence Island. These models show those conditions to be much more normal than they were back in 2018, when that was the first time there was ever that low of an extent in April. Sorry, I think I interrupted you there.
I have a question. Dean, did you get your answer?
Yeah, I think he's answered most of them except the last one. What
Okay.
about prey?
Yeah,
Yeah.
we have. I am not aware. I'm not aware that our samples would be the best sample to look at. I think that the Alaskan Department of Fish and Game probably has the best data set for those. They work with a couple different communities every year collecting samples, stomach samples from harvested animals. So they get full stomachs, not just the scats that we're able to collect. And from those, I do believe there have been some prey species that have shown to change over the last 20 years. But off the top of my head, I'm not able to give you those exact species. But I do believe that they've produced a report. And if you reach out to me after this, I can try and find that report and send it to you.
Yep, much appreciated. Thank you.
So just to follow up on that, I do see the messages in the chat, and I do see it's too small a lettering for me for these glasses, or lack of glasses. It says Ildiko. I'll get to you right next. But my question following on this is looking at that graph under why we should care. The red, is that the ice as it is now? And then the blue and the pink are those, I guess the gray would be all the model
That's exactly
runs.
that's exactly right.
What are
And
the
this is actually about a decade old now.
I
This
see that,
particular
but
figure
yeah.
came from our status reviews. So the red line is sort of the actual, or what was
Okay.
actually observed, which
Yep.
ends here. So you probably have to add another 10 years to that. The gray squiggly spaghetti in the back, that's all different model runs. So hundreds of model runs, all kind of showing you the variability. And then the blue and the pink are different ways to interpret those multiple model runs. So
Okay, kind of a
the
median.
takeaway from them is all of them are declining by
Yeah.
the end of the century.
Okay, no, thanks. And and I think Dean had a really great question regarding prey, because up here, and I know you maybe you can't answer that right here, but it's a big question because of the massive sort of ecological shifts that have been going on with the marine environment in the northern Bering Sea, Bering Strait region. People here have been living through sort of hard to imagine the scale and scope of having, the amount of pollock show up, the amount of Pacific cod show up, having the seals respond being so thin and so forth to trigger an unusual mortality event. So I know diet is a thing on everyone's mind. So that's probably where that's coming from. All right. And yes, thank you. With your hand up, let's hear your question. Go ahead.
Okay, is my audio coming through all right?
You're coming through great.
Okay. Oh, and for Subgate, thank you on the name pronunciation. You're one of the few people who actually got it right on the first try. Usually
All
people
right. Well, with a name like you kind of try to get everyone's name right.
I can relate to that. Anyway, thank you, Dr. Cameron, for the presentation. And I have a couple of questions on ribbon seals specifically with your data. They were actually the focus of my Hollings project a few years back, and I've been curious about further findings with the ice seal vessel survey. So two questions mainly. One, in 2022, were there any further ribbon seal captures or sightings? Because I understand that there were issues with that in 2018.
Yeah, so that's a really good point. So in 2018, there was very low sea ice in that year, so low that we needed to move very far north of St. Lawrence, which is a region we've never had to move to before. During that cruise, we were very surprised to not see ribbon seals. We only saw a small handful, whereas normally that's what we're mostly being able to see and capture out there. At that time, we weren't sure where the animals were. We talked to colleagues in Russia. We talked to Alaska Native hunters to see if they were seeing super high numbers of ribbon seals choosing to haul out onto the coast at that time. No one reported seeing anything particularly out of the ordinary. The fact that we weren't seeing a lot of ribbon seals on the sea ice meant that we didn't know where they were or something particularly bad had happened to them. The assumption then is that ribbon seals, as deep water divers, were best able to forage off of the shelf in deep water. With the sea ice so far away from the shelf, there was a question as to whether or not the ribbon seals chose to stay where the deep water is and forage, or if they chose to stay where the ice was and give birth to their pups. The fact that we didn't see a lot of seals on the pups, seals or pups on the ice in 2018 led us to believe that perhaps there was a loss, a big cohort loss, where there weren't a lot of pups being born. I later learned that there were some increased vocalizations of ribbon seals further north of the Bering Strait in 2018, but I don't know the extent to which those were had any relation with pups. So that's just a bit of background for folks that don't know the background.
Because that was my project.
Oh, great. So I wanted to make sure that other folks knew the background. So the answer to your question is, did we see a lot of animals in 2022?
Yes.
Short answer is no, but like everything, there's caveats. 2022 was also unique in terms of its sea ice. It was actually looking like it was going to be a bit of a normal, quote, normal year, what we have been more used to. But at the very last month, there was another cold snap, which added about 30 miles of sea ice, unformed or poorly formed sea ice that was too thin for a seal to haul out onto, but too thick for our boat to be able to push through safely. And so what that basically meant was we didn't see a lot of any species on that cruise, but I'd hesitate to say if it was because there just weren't seals out there. It's just as likely that it's because we couldn't get to where the seals probably were. So I can't answer your question, unfortunately. That's one reason we're very excited for Erin's project, the aerial surveys. They don't care about what the ship cares about. They're going to be able to fly over all of the sea ice and be able to get us a good abundance estimate for all of the ribbon seals. We can then compare that abundance estimate to the ones that we collected for the Bering in 2012 and 2013, and for the first time actually get trend information on the change in the population. So we're optimistic we're going to be able to answer your question next year, but unfortunately, I can't really say much based on what we saw in 22.
Yes. Thank you for the additional information. And it actually was very interesting that you mentioned the potential split in behavior for ribbon seals, some remaining with some potentially facing this choice of going up to the radically diminished sea ice edge to continue typical breeding season activities versus remaining off the continental sea shelf for better food foraging possibilities, basically, because I actually did see potential evidence of that in my acoustic data review. During the 2018 and 2019 years that I reviewed, there were these hotspots of acoustic activity in the southeastern Gulf of Anadyr, far away from any sea ice, which would lead very nicely to that possible theory of there being this split between the choices, because there was falling up northwards of the sea ice, but there was also this activity very far from any of the sea ice extent.
What month were you seeing high activity? Was it April, May, June, or later?
May and April, mostly mid-April.
Huh. Well, that is very interesting. So I guess I had just heard rumors about those data, but it's now I'm talking to the person that's analyzed them. So that's great. We should.
Both of you I put Michael's contact information in there. get your Kemper info in there and he'll get a hold of you. Yeah, you guys can talk
Okay,
Rebenseel spec. That's awesome.
Okay, I'll have my personal email in there. I ended up getting kicked out of the NOAA account after the hauling scholarship ended, unfortunately.
Rough.
And I actually do have, I worked with Daniel Woodrich from a project, and at the end he put together this very nice time-lapse video of all of the acoustic data that I had unlocked together along with the sea ice extent. So I could just attach that as a video clip to the email. It shows everything very clearly.
Terrific. Thank you. Thank you so much.
Seriously, put your contact info in. We may want a straight science on that. Come on, that sounds awesome.
I
Seriously.
actually, I feel like I'm using the word actually a lot here, but
It's all right.
I just put in my fellowship application for the National Science Foundation, and my project proposal was actually based off of an extension of this ribbon seal data. And I brought up straight science presentations as a possibility for future follow-ups.
You're in. With that, you're in.
Thank you. Was this the audition? This was.
Yeah, and you're a good speaker, so it's all good.
Thank you. And I'll lower my hand to let other people speak.
All right. And you bring up a really good point too, about not just Gulf of Anadyr, but these seals are transboundary, right? Not just with Russia and the Gulf of Anadyr, but they're transboundary with Japan and everywhere else. So really, to me, ribbon seals are a seal of the Western realm outside our maritime border, and we're graced with their presence when they come in. And they'll, because somebody doesn't see something on a ship or a certain month of flying, know that, ribbon seals are sort of, they just show up, then they take off again, and they can show up in great numbers. And they are, in Dillingham, they can get ribbon seals, Kuskokwim area, the Yukon-Kuskokwim region. So they are kind of bombing all around. So think transboundary. I like that. And Dean, you had your hand up. I don't see it. Maybe.
Yeah, I did. I was kind of curious. You're talking about a north-south difference in populations. What about an east to west?
Yeah.
We're definitely seeing east to west changes for ribbon seals, for example, where there's more ribbon seals to the west.
Gotcha. Thank you.
But, yeah.
When you say east to west, what do you mean? I mean, which part of Alaska? You're talking about eastern Bering Sea, and to me, that's way down below Norton Sound or Seward Peninsula.
Yeah, no, that's a good question. I should have specified. So in the Bering Sea, for example, which is the primary location where there are ribbon seals in the spring, there are more ribbon seals the farther west you go in the Bering Sea. So as a latitude by latitude, there's more ribbon seals the further west you go toward Russia.
I think OPIC kind of getting in that Anadyr current. Lots of good food, maybe. Don't know.
Yep. Lots of good food. Lots of, seal, lots of mammals, lots of walrus up in that area that time of year too.
Animals.
I did have a question.
Go for it.
I put it in the chat for Mike.
Okay.
I gotta find it. Okay, here it is. So anyways, so Dean asked this question, but my question, I mean, he asked about the decline of seals in the regions. I was thinking, what's the decline number of seals by different areas or regions, or did you collect that information?
I think so. We weren't talking about a decline in the seals. We were talking about a decline in sea ice extent.
Oh.
So we've recognized that over the past decades, there's been a reduction in the southern extent of sea ice in the spring, and computer models have predicted that decline in sea ice is expected to increase, if that makes sense. A loss of sea ice is expected to get faster by the end of the century. So we were talking about sea ice and not seals specifically.
Okay. But so anyways, with that question, I mean, when you're doing your surveys in the different areas, Are you also doing population count on those seals?
When the aerial survey work that we do is our best way of being able to estimate abundance, how many there are in distribution, where they are. The Alaska is a huge area, and as such, it takes a long time to kind of survey the whole area. And what that means is we've only actually completed one survey of Alaska in the last decade. We don't have a trend yet. A trend is a change from one year or one period to another. All we have is a single data point for each species on what their abundance is. Erin's work over the next 2 years in 24 and 25 will be able to give us the answer to the questions that you're asking, is to,
Okay.
are there changes in abundance? And if so, where are we seeing those changes in abundance?
You know, and if I'm thinking up in our area in the Bering Strait, I think it's gonna. I know with the increased shipping, we're seeing so much more shipping now than we ever did. You know, there's gonna be changes. There's gonna be big differences in numbers of your seals, and of all mammals.
Changes in sea ice are impacting everything, including what humans do. And then what humans do, like in terms of shipping or changes in fishing distribution, we could expect to have knock-on changes to these populations.
Yep.
All
And
right.
that 2018 year, February, our ice breakup was so early that it marked the first in our Diomede lifetime to see ice breakup. So early when it should have been frozen across the strait.
Well, we are hoping we have good ice in 24 and 25, that's for sure.
Yep, me too. I hope so too. I love that ice.
So, can I jump to the chat real quick, Opik? Or you have another question?
No, I'm done.
Okay. So I know Erin was sitting on and has already answered this, but just so everyone sees, Erin, this is from Colleen, the distances you cover on aerial surveys is just amazing. And I would say that is the case. You are going some long distances offshore. How high can you fly over seals and still get a heat signal on your infrared image? And Erin, the answer was, thanks, Colleen, our upper limit of 1,200 feet is based on seal detectability in the thermal image. The thermal cameras are lower resolution, which limits our altitude a bit. Any comment or anything you wanted to add to that, Erin?
Yeah, actually, I think I'm not sure I actually answered the question.
Always good to read them.
At what altitude we actually lose visibility of a signal of a heat signature, and I don't know that I have that answer right off the top of my head. We did do some focus studies using some flights over glacial harbor seals where we could do, we could access animals relatively easily and reliably and flew at different altitudes to look at where we started to lose detectability, which was our primary question. I think for larger bearded seals, you could go quite a bit higher and still detect bearded seals, but ring seals are, what we lose first, of course. And so we set that limit, that upper altitude limit based on when smaller animals started to disappear. So now I'm curious, though. I'll go have a look back.
All right. And then the question from Doug Molyneux is, seals fitted with radio transmitters. In any given year, how many seals are fitted with transmitters? And is the transmitter info used to inform distribution in season?
Great questions. We are not the only group that puts satellite tags out on animals. Our group, we only put satellite tags on ice-associated seals, well, lately, every other year in even years. When we put satellite tags on a seal, we tend to put them, we have two different types that we put on. One that we glue onto the animal's fur on its back, shoulder blade, and another one that basically is like an earring, only it's in the rear flipper. The one that's glued on lasts as long as the animal molts. So if we grab an animal in early April, that satellite tag will probably only last 3 to 4 weeks before falling off. If we're able to capture the animal in, late May, that has the potential for staying glued onto the animal for up to 11 months before falling off and providing data. The tag that is connected to the animal's flipper does not give us information on dive depth, but it does give us information on location and timing of haul out. Those tags on some animals, we've had bearded seals that have held them for up to 3 years at a time. So to answer your question, takes a little bit of guesswork. Our program probably tags, let's just say 20 animals every other year. And depending upon the tag, a number of those would be persisting to the following year and to the following year. But the Alaska Department of Fish and Game and the North Slope Borough also have very robust, large tagging programs. And they're tagging mostly ringed and bearded seals and some spotted seals. They're maybe tagging, I forget where they are now. They're probably on the order of 5 to 10 per year. So if you add all those up, that can give you some idea of how many animals, how many tagged animals there are in any one year.
And the other answer too would be to contact the NOAA permit office, because everybody's got to have a
That's true.
permit.
That's
and
right.
you could easily contact because let me tell you, it's hard to keep track. Michael just did a good job in thinking on all the different projects, but I would contact the NOAA permit office and ask them, and I don't know where that's located, but it's probably Washington, D.C. or Silver Springs, Maryland would be my guess. Maybe Michael or Erin or.
Yeah, it's on the East Coast. The Marine Mammal Protection Act would be able to. That's all public record. Everyone who works on marine mammals has to report once a year on all the work they do, not just tagging, however many animals they handle, or even a good estimate of how many seals they flew over. So all that stuff gets recorded and reported once a year. And
that would be an interesting deep dive itself into what's going on a sort of a statewide perspective on tagging, handling, and disturbance. And things like that. There is a comment, I guess, from Phil McGilvery. He's with the U.S. Coast Guard Icebreakers, and he says, moving to unmanned aircraft surveys like by UAF Sea Hunter, 1,200 mile range, ? Is that, I'm unfamiliar with that UAF Sea Hunter. Is that and Phil, you're still on. Is that something you can talk to us about, or if I got your question correct? Any comments?
I can give a comment.
Okay, you know this one.
I know a little bit about it. University of Alaska Fairbanks has a Beyond Visual has a long range aircraft, unmanned aircraft that they're working with testing. Being able to fly an aircraft so far away that you can't see it involves a lot more paperwork and restrictions with the FAA, as you can imagine, to fly, even in spots that have so little other air traffic like Alaska. That being said, our program, we also have a program that we're working on for harbor seals to be able to use a long-range unmanned aircraft based out of Shemya, where we're currently testing to fly. I think our longest right now is 50 or 60 miles away. We've been able to fly this thing, get permission to fly it. That's the hardest part, being able to get permission to fly it and conduct aerial surveys of harbor seals along the coast. Using an uncrewed system to cover the distances that we're covering at the altitudes we need to cover and the speeds using the payload we need would be pretty difficult with current technology and regulatory capabilities to be able to cover the sorts of areas we need. We are planning in 25 to be able to do a test based out of St. Paul to fly over the sea ice and start looking to see how well we might be able to use unmanned aircraft, but likely unmanned aircraft is going to be best used for smaller restricted areas that are better covered with unmanned aircraft than manned aircraft. So it's something we're looking at, but we're not ready to quite take the jump yet. In our experience, the manned aircraft is just a better, for a lot of the work that we do, is a better platform overall.
I'm going to pipe in here.
Erin's been involved in both projects. I should have let Erin jump in.
Well, I'm a huge fan of the concept of using long-range drones to help with ice seal surveys in general. I think there's definitely some areas that are a bit sketchy and hazardous to have people in planes at 1,000 feet, and it would be great to have something that is, even though they're slower, they can fly for so long and be collecting data. So I think it would be awesome to be able to incorporate them. And then in addition to that, for these areas around communities where we're intentionally not flying, it might be that communities might be more comfortable with a smaller drone, especially if we put some decent cameras on it. It could fly higher. It might be a great avenue to help bridge some of those gaps that we end up with because of those buffers. So we did a project a million years ago to explore flying drones from the ship, and that was in 2010. And I think that program at UAF seems to be one of the only places that has focused on the icing challenges of the Arctic. There's not as many, a lot of the, maybe with, changing political dynamics, maybe there will be more focus on that type of solving those kinds of challenges in the future. But yeah, it feels closer now, Mike. But yeah, it's still a lot of paperwork.
All right, Dean's got a question, and then so do I. And how are you guys? How are our main speaker plus Erin and Heather? You guys holding up all right? All right.
As long as people have questions, I can stick around.
All right. You're the right crowd. Dean, go ahead.
So oceanographically, coastal Alaska is a lot different than coastal Russia. So how do you address the differences of maybe a population shifting to the east or to the west, depending on what they're seeing in a reduction of ice? Basically, ice algae is decreasing. Those are the basically carbon components that feed the benthos, that feed the fish or the organisms that feed your seals. So how do you address something like that when you're limited by what you can really address yourself?
Yeah, so that's that is probably our number one biggest challenge at the moment. And if you remember for the 2012, 2013 surveys of the Bering Sea and for the 2016 surveys of the Chukchi Sea, we were able to coordinate and cooperate with our Russian counterparts on the other side of the international date line. We had multiple meetings where we made sure that the methods that we were using, the instruments that we were identical, the methods we were using were comparable between the two. We were conducting the work at the same time of year in the same months. So ultimately, because we had done that prior planning, we were able to bring the data sets together in order to get a full estimate in 2012, 13, and 16 for those species that cross boundaries. With the issues right now, politically, you can imagine it's not something that we can do to be able to have the same level of cooperation with Russians on their side. We still think it's very important to be able to conduct this work. One of the reasons that we're planning to extend our vessel-based surveys in 2024, next year, from 3 weeks to 6 is because we want to be able to put out a lot more satellite tags on seals so that we can have a better idea. And a lot of those satellite tags we'll be putting on will be the tags that will stay on for 3 years or more. We want to be able to use those data to help us have a better idea of cross-boundary movements of animals, and hoping that we might be able to use those to help us get some better ways of estimating total populations. It's not going to be as satisfactory as going out and being able to have the Russians survey their side and then work together to combine the data. But we can only do what we can do with what we can do. So we're gonna do our best, but it is definitely something that we're disappointed that we can't have the same experience in 24 and 25 that we were able to have in 2012 and 2013.
Thank you much. Really appreciate it.
Yeah.
All right. All right. So, thank you, Dean. So my question is, well, first off, not a question. I just want to say thank you for your program's communication efforts. I mean, you've been going to communities here. You're going to be in daily contact with your email list, with the tribal offices in the region, with maps, VHF. You know, you're really doing a great job planning for comms to make sure if someone has a question or a concern, they can get a hold of you. Or I'm sure Coeric, myself, everyone probably get a call if there's something that they really need to get a hold of you on. So I am really happy about that. You know, one thing we were talking about earlier before we started was the region here. You know, you're going to be flying your survey. When actually will we see you in Nome? And is that, if we shut down the government for a little while, you guys are still on that won't bother you? I'm sure they'll get there. We'll all
Go
be
ahead,
all...
Erin.
Did you just ask if the government shuts down, if that will not bother us?
Well, are you guys are safe with your funding, and we'll see you in Nome, and when will that be? As best you can
Well,
get.
as long as, if the government shuts down, as long as it opens back up, we'll be there.
Yeah.
So we'll be in Nome and St. Paul in April, and we don't have, generally it'll be pretty, weather focused on where we go. So if the weather looks better at a Nome, then we'll head that way. So it's very in the moment, as opposed to a scheduled week here and a scheduled week there kind of thing.
All right.
But it's fair to say that the start point will be sometime around like April 3rd.
Yeah. First week of April.
That's good to know. Thank you for that. And the thing is that this summer, and Phil McGillivery's still on, and I'm sure he knows a lot more, but that OPIC was talking about the industrial maritime traffic in the region. We have had a phenomenal amount of traffic on both sides of the EEZs, right, on either side of the maritime border, but primarily on the Russian Federation side. And these are rather large ships. There's also, given the world as it is, we had a United States military drill from August 23rd to September 10th from St. Lawrence Island to Shemya to Attu and up the line. And when that ended on September 10th, the Russians announced their military exercise, which would take place 4 days later, from September 14th to the 24th. And that actually came into all legal. They notified NORAD. They came into our EEZ. They did the Gulf of Anadyr, wherever they went on their side of the line, and they came all the way down into the southern Bering Sea in the US EEZ. So for about a month, marine mammals in the Bering Strait region to the sort of the western side were really likely inundated with a lot more, not just ship noise, sort of, transit noise, but probably sonar, munitions, ordinances, that sort of thing. This was a military, I think they had missile operations, and not sure what we did on our side. But the point being is that there were a lot of more than one kind of local observation that seals were hard to see in the area at that time. You know, you can kind of imagine that you're making a lot of noise. We have a lot of ship traffic anyway, but then you add in sort of the not just industrial transit of these 1,000-foot tankers we're seeing on a regular basis now, but these military ordinances and exercises and things like that in the same area. Are you, or will you be coordinating with Homeland Security and or Navy so that when you're flying in April, that the lack of seals is really a lack of seals? It sounds like we will be having, I think Rootin' Tootin' Putin is saying that starting in 2024, the traffic of those ice-capable LNG tankers, those are the 1,000-foot tankers, that those will be unceasing. Now, I don't know if that means, and they are unceasing right now, I don't know if that means they're going to carry on now right on through the start of 24, or if they're going to be a cessation and then start up in 24. But we're not seeing any, we're seeing those vessels coming through still. Is there, just as a thing, is that something that might be useful for you guys to know, to sort of coordinate and see, is there some sort of operation or something like that, so that you're getting it's so noticeable now, the ship traffic, and so noticeable that we had boom, these two exercises at sea. So in the US EEZ, they came, the line where the Russians claimed they would come was within 16 nautical miles, 16 miles of Gamble, which is on the northwest side of St. Lawrence Island. So they were really close to areas and in areas where you may fly. I have no more idea than a rabbit what is planned, but I was thinking about that as you guys were talking and as we were talking earlier, and I wondered, that's something you've never had to think about, really. I mean, in spring, is having that. So I didn't know if checking with Homeland Security, the U.S. Coast Guard, or the Navy might be something at a federal level you guys could.
Well, I think as far as that was aircraft or ship, the 16 miles, within 16 miles of Gamble.
Everything.
Both.
Mhm.
I think
Claimed
large
that was
scale
their area.
military operations like that are generally known by our aircraft division, because they have to be marked and communicated for aircraft traffic in general. So I think if there was aircraft activity, then our pilots will be aware of it. For ship activity, I don't know how. I know we would be able to look at ship tracks that are. I think that there's some availability. There's some processes where we could look at ship traffic if we didn't, if we needed to dig into a particular area, not seeing what we expect.
I don't think they're going to have their AIS on, and that's
yeah.
And so this is military now, and they will be making different kinds of noises, and it may not be in our EEZ, right? It could be just going on next door, and they don't let you know.
Yeah. I see what you're saying. You're saying if they're doing operations on their side of the line, are we going to be aware of it?
Because
you're
concerned. Your concern, Gay, I think, is that it should be something we should use potentially as a covariate in modeling, because if there's increased ship or aircraft traffic, it might be changing the distribution of seals beyond what they might otherwise be in the area. And so we need to pay attention to that, is I think what you're saying.
Yes, you're right there. You're better at me than vocalizing it. And especially military exercises, because they are letting off sonar, they're
Yeah.
blowing stuff up, they're launching. We had submarines and all kinds of things you wouldn't normally think of when you're far from this region. You're going to be thinking, oh, it's just the empty Arctic, or it's quiet. It's not like that. It's not like that really right now. And we're seeing such a difference in the amount of traffic. And I think Phil was nice enough to put something in here. Phil McGilvery in the chat predicted 15-fold increase in Russian oil shipping. That's just Russian oil shipping via Bering Strait in next year. Cannot comment on military. I'm sure he can't comment on the military, blah, 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 but it's expected. So if that's something you may want to, because if you see like there's no seals and all of a sudden you say, hey, wow, our population is really down. Maybe they all just scooted up into the Chukchi or went ways wherever your plane didn't go because it's just darn too noisy. And I would hate to have that be the covariate that isn't explained as to why the numbers would be down. Anyway, know that because during the time of those exercises this year, there was some observations locally made on the coast here in the Bering Strait region that where are the seals? And it was close to the maritime border.
Gay, I think one of the things about military exercises is that sometimes they are publicized and we're aware that they're going on, but a lot of the time they're not. So I think even if we were coordinating tightly with the military, that they're not necessarily going to tell us where they're doing exercises. I know that from experience of seeing and calling and questioning and being told I didn't see what I saw. So I think there's only so much we're going to be able to get through a conversation like that, but maybe, I don't know.
I think it would be worth at leadership levels to have that conversation with the other agency leadership, just to see if there's something so you guys can get at least one, because it's important what you're doing and you want to make sure you're covering that. If there's
hopefully we'll be able to, if there is a lot of activity, hopefully we're going to be able to pick up some of that in the imagery as well. We'll see. Maybe not submarines.
You can pick up that imagery. I'm not sure if you're aware of Arctic Watch. I know you're familiar with Marine Exchange.
Coast Watch,
So, So
Arctic
these guys, they can set up an AIS with your tribal communities. Geofencing. So, you can turn on your computer and you can see all the ships that are entering and exiting the Bering Strait on both east and west side. And I see them daily. Much ship. Back and forth.
That's a great reminder, Opik, and I appreciate that. The ships I'm talking about for military, they don't turn their AIS on. They want to go stealth mode, But yes, you are right, and thank you for mentioning that.
Yep, and Francis did take a picture of one yesterday that I didn't see from my emails. I didn't see the name of that ship, but it was there this morning.
Yep, we've had those big nuclear icebreakers right on through into. You can see them right from the beaches of people's communities, coastal communities here, all lit up.
Well, if you guys wanted to do some kind of science and with seals and come to Dimey, bring your drones. We don't have air traffic so much. We get a once a week, maybe weather permitting helicopter, that flies twice, but other than that,
make those
would be a good place.
Make those border guards really question what's going on over there. What's Dimey doing with drones right there? But no, thank you, Opik. That's super.
Yeah.
Yep.
All right. Well, I think we've probably given our speakers a run for their money right there. My goodness. So we thank you very much. Are there any other last minute questions? Really good discussions. I thank the audience. I thank our speakers. Next week we have on Thursday the 26th, we're going to have a straight science kind of tradition now. We're going to have Rick Toman. He's with the University of Alaska Fairbanks Alaska Center for Climate Assessment and Policy, and he's going to be talking about Western Alaska's summer. and what happened there. And so we did not, it was the warmest summer on record in the Arctic, and we did not keep step with that. We went cold, we went rainy. Rick's going to explain it. He's also going to talk about the El Nino we're in. What does that mean for us? And he's going to give the projections for the winter outlook as to what we should sort of buckle in and expect to see. I think Michael and the Polar Ecosystem Program team, I hope we see you here next Thursday night, or 7:30 your time, 6:30 our time, because I think that'll be really interesting. And there's also, there'll be a woman, Caroline Erickson, who will be, she's working on getting some fact sheets together of extreme weather events, working with Rick. And so she's going to talk about what she's found and where we can get a hold of those. So with that, we look forward to seeing everybody. Thank you again, Ice Seal Polar Ecosystem Systems. I learned something. Systems program. And you guys have a good night.